So welcome to the first tutorial session of problem solving through programming in C. And so this is a SWAM course which is floated by Professor Anupam Basu from Department of CSE, IIT Kharagpur. And I am Siddhant. I am one of the three TAs who are in charge of taking the tutorial classes for this course, where we will be solving a few questions and recapitulating on the concepts that have been covered through the weeks and the weekly lectures. So, in this session, because we are having a session after with a delay of a week or so, I'll be covering both the tutorial, both the week 1 and week 2 material for this course. So let's start with the course. We have so what exactly is problem solving? So problem solving is basically uh, reducing any larger problem into smaller logical sequences so that we can solve each of the sequence using programming. So basically, if you think about it, what you need for the most important thing that you need for programming is logical thinking. So, what exactly is logical thinking? Logical thinking is basically the ability to do this. That is to reduce any larger problem into smaller logical sequences so that it can be easily solved. And I'll give you an example of this. Um, say you want to find out, let's say an example. I want to print all factors of 50. Okay. So if I want to print all factors of 50, what I would do is I would first think of what is a factor of a number, right? Once I have answered that question, that what is a factor, anything that that when the number is divided by that number, then you'd get uh, zero remainder. That would be a factor of the number, right? Now the second thing that I would think about is what can be a factor of a number of a number. Right now, say if 50 is a number, then anything from 1 up to 50 can be a factor, right? So this is basically okay. Like it would be great if you can join on time. Okay. Um, right. So now what I would probably think is let us try dividing 50 by all of these numbers and check if it is perfectly divisible or not. So I would divide 50 by 1, 50 by 2, 50 by 3 and so on. And if it is perfectly divisible, then I would say that that particular number is a factor it is a factor of 50, right? So that is how I would check, and I would probably print all the factors of 50. So you can see here what I have done is um, basically I have divided this problem that we had, that is print all factors of 50, into small steps, and I'm following those steps and I am checking whether and finally I have been able to figure out all the factors of the number 50. Okay, so that is the part that is mostly required, that is of most importance in programming. You need to think logically and figure out what is what could be the sub steps, or whether that big problem could be divided into smaller steps and each of them could be solved using some kind of programming. The programming comes later. That is what I will cover throughout this course, but you need to develop this logical thinking. Okay. um, so basically we go to the next step, and we see what is an algorithm. So algorithm basically is the set of instructions that can be used to solve a problem. So in the earlier example, we had a set of instructions that we developed um, to find out all the factors of the number 50, and we that is basically what is an algorithm. So how would you go about printing all the factors of a number? That is what the algorithm is all about. Now you can have different ways of explaining.
Excuse me, sir.
Yeah.
Sir, some students are waiting in lobby. Please admit to him.
Okay. Okay, yeah, I've admitted them. But yeah, it would be great if you could join on time because we are already 10 minutes late here. Okay. So there can be different ways of explaining an algorithm. The first is using flowcharts and then using pseudocode. The pseudocode part has been covered in class already. It's basically something that would be like less technical than your code that you would write, the C code that you would write, but it would explain what exactly is to be done um, for achieving whatever or solving whatever problem that you have. Right now, flowchart is another way to solve this. Flowchart is another way to solve this. To give a set to write a set of instructions to solve a problem. Now, a flowchart is more or less a pictorial representation. So you show it using some kind of pictures, and how exactly you have a few like depending on, I think in the class it has been covered, but I'll just briefly go through it. So you can have different boxes of different kinds which would represent, which would have different meanings. So you can write start or stop using these oval boxes. Then you would have this rectangular boxes for any kind of operations. You can have parallelograms for input output operations, and you can have rhombus boxes for decision statements, then connectors, on-page and off-page connectors, you can have represented by circle or this kind of symbol. So it really, the notation varies. You can have different kinds of notations for um, you can have different kinds of notations for the flowcharts, but ideally try to follow a single notation which would be useful for you. Okay, now so let's see an example, that is to find the number of, or rather, let me just simplify this example for you. So let us, so I would say, just enter a number and check if it is, if it is positive or negative. So let us just draw a flow chart for this first. So what I would do first is I would um, start it from somewhere. I would ask the user to enter a number. I would print that enter a number, right? And then I would take the number as an input from the user. So the user would input, say, n, some n. So the user has inputted some n value. Now what I would do is I would check if n is greater than 0. Now if it's greater than 0, if yes, that is y represented by y here, I would print that n is positive, right? And if it is n, that is no, it's not greater than 0, then I would again check if n is less than 0, right? Because it can be equal to 0 as well. So I have asked only for positive and negative. I have not asked for 0. So if it is less than 0 and the answer is yes, then we would say it is n is negative, right? We'll just print this out. Okay, and now if it is false, nothing. Then we don't really need to do anything. We'll just go to the stop part. So I'll just write a stop this, and I would connect this here and this here. So this would be our flow chart, very rough representation of a flow chart. You can draw it definitely better than me in here, but yeah, this would be roughly how you would go about checking a number, asking the user to input a number and checking whether it's positive or negative. Okay, if it is clear so far, you can just yeah, you can, shall we move ahead, or you can ask any questions if you have. You can turn off your, I think some of you are having issues with the audio and so on. You can probably, the others can try to turn off their videos so that it would save some bandwidth for the others. Yeah, yeah, please go ahead.
If n is less than 0, it is no. What would be the output there?
And we don't really need to print that output. You could print that n is 0. That means, okay, if n is if n is not greater than 0 and n is not less than 0, that means n is 0, right? So I could print that n is 0, but it's not really asked in the question. The question asks whether it is n is positive or it is negative. So I only need to focus on those two parts. I don't need to focus on the case where n is 0. So I have not printed anything in that step. But if you want, you can just add a thing here that n is 0.
Thank you.
Yeah. Okay. All right. So let's go to the next slide. So I'll just briefly uh, give you an overview of what has been already covered in the class. So the components of a computer, we have the input. This is the input section, and this is the output section. And you have the central processing unit consisting of ALU and of CU. ALU, arithmetic processing unit. CU is the control unit, and the CPU exchanges data with the main memory or the internal memory, which is the RAM. And then you have different kinds of secondary memory where it is stored for a more permanent usage, for example your hard disk and your USB and so on, whatever USB. Okay, apart from all this, you still have other sorts of memory, such as you have memory registers and cache memory. So you have L1 cache, L2 cache, and so on, but you don't really need to go into the details of this until you are trying to learn more about the memory architecture, which we will not be covering in this course. So these are the different components of a computer. Now, again, another overview of the different number systems that are present. Um, yeah, the different number systems that are present that we will use mostly in like these are the usually used number systems in programming languages. There can be others as well, but these are the ones which are used more frequently. Okay, so there are different number systems. So first is the binary number system, which the computer uses. So the computer recognizes only this number system. Okay, you have the binary system that is of base 2, and that consists of only the digits 0 and 1. Yeah, you wanted to ask something, Malesh? Yes.
Yes, sir. How can you speak with the
Uh,
PDF, sir? Explain to that.
how can we? How can you?
Send to the PDF, sir, in this programming, sir.
You will find the PDF after the class, probably after a few hours. Once the class is done, you will find the PDF in the in the course page.
Okay, sir. Thanks, sir.
Yeah. Okay. So we have other number systems, which is octodecimal number system, where you have digits from 0 to 7. You have the decimal number system, which is base 10, which we use, which is having we use in daily life, right? So it has a base 10, and hence numbers from 0 to 9. And then we have a hexadecimal basis, which is base 16, and you have the numbers 0 to 9, and then A, B, C, D, E, F. A representing 10, B representing 11, C representing 12, 13, 14, and 15. So these are the commonly used number systems. You can define a number system with any base. So if I want to define a number system with base 3, it will have the numbers 0, 1, and 2. So I can define a number system with any basis. So these are the commonly used number systems. Okay. So let us just see a very basic conversion, how to convert a binary from a binary number system to a decimal number system. Yes, K. Kumar, do you have anything to ask?
Good evening, sir.
Yeah, good evening.
Sir, actually, I have small doubt in this numbering system.
Yes.
Sir, why we need to learn this numbering system?
Okay. Actually, you'll know about it a bit later, but for example, in our systems, the addresses are always stored in hexadecimal system. Why? Because it can using less number of bits, you can have a much larger data being stored there. So say currently the memory systems that we have, they have they have very high capacities, right? So we are talking
Yes,
about
sir.
TBs, 1000 TBs, and so on nowadays. But
Okay, okay,
if you want to number such kind of systems, such kind of memory spaces, if you want to number the bits and the bytes of those memory spaces, you need a really large number in order to
okay,
number each of them. So uh, in that case, you would be using higher base systems like hexadecimal system to have the addresses being
okay,
stored, so that we can in less number of digits we can express the same in less number of digits we can express the memory location or the number that corresponds to that particular memory location. So that is basically
okay.
why we learn the different
Sir,
numbers.
actually, these four number system already there in the beginning of the C language. That means in the early century 1950,
Yes,
or
this
itself.
is much older. This is got nothing to do with programming itself.
Okay,
This was there much
okay.
before, like it's mathematics. It's not programming. We have not gone to the
Sir,
programming part yet. Yeah, but
sir, one more
yeah,
doubt. One more doubt.
yes.
Sir, actually, this for representation of the memory address for purpose only, we are learning hexadecimal and decimal octadecimal, right? Not for the binary, right?
And not for the binary. Binary is because the computer can understand only binary. It is the simplest number
Yeah,
system,
yeah,
and
yeah.
that is what the computer
Okay,
will understand. Yes.
okay. Any data, whatever the data, whether it is video or audio, whatever it may be, that will be converted into the numbering. That is only the binary. That is
Yes.
understand by the computer, right?
Yes.
The other numbering system, it's a representation of the memory number. Am I right?
Yeah,
Memory
like
number.
that is one of the uses of hexadecimal system. But
Okay.
you can have different uses. Like basically, we use such kind of number systems to represent larger numbers. Like mm, you can use higher base systems to represent larger numbers.
Okay.
That's all.
Sir, one more thing, sir. One more last doubt. What
Yeah.
about the supercomputer? Supercomputer is also following the same number?
See,
Supercomputer.
any computers follow the same. Like finally, you need the computer can understand only binary language. So any kind of
Okay.
computer, no matter supercomputer or cluster computer or
Okay.
whatever, finally you need to convert it
Okay,
to
sir.
binary. But yeah, you can store data. The address can be stored in hexadecimal. It is actually stored in
Okay, sir.
hexadecimal in all the computers. You will
Thank you,
find,
sir. Thank you.
yeah,
Thank you so much. Thank you. Thank you for your
yeah,
clarifying notes.
sure. All right. Okay. So, Ramakrishna Biswal, do you have a doubt? You can actually write in the chat as well. If you have any doubts, you can write in the chat as well. That is fine. Manish Jangir.
Yes, sir. Good evening, sir.
Yeah. Good evening.
Sir, I had a small doubt that what kind of number system is more preferable and more usable in oh, binary number system than, but I mean, decimal or hexadecimal?
Um. See, hexadecimal. Okay. Let me just. I'm not sure about the octadecimal, but the hexadecimal number system, as far as I have seen, it is used for memory addresses in computer systems. The decimal is used because that is something that we use in normal life. Like you don't say numbers in hexadecimal form, right? You say numbers like if I say 90, it's decimal. So that is why you we use decimal systems, and binary is used because the computer understands it in binary. It's the simplest system, so it understand binary. So these are the purposes of these three number systems.
Okay, sir.
Yeah.
Thank you.
Okay. All right. Sharon, do you have any doubt? Okay. So we were converting it from binary to decimal. So you can understand it's binary because I have written the base as 2. So I have written the base as 2. You can see here. So this is how you would represent the base of a particular number. Say you have a number which is 1011.101 here, and you are saying that it's of base 2, and I'm asking you to convert it to base 10. That is the decimal number system, right? So what do you usually do? So you just write down the number for converting anything to decimal. What you do is just mark this dot here. So what we will do, you will multiply it accordingly. I'm just writing it down first, and then I will do the multiplication. Okay. Now I'll multiply each of these numbers 1011.101 with their corresponding power of 2. Alright. So I'll multiply 1 with 2 to the power 0, 1 with 2 to the power 1, 0 with 2 to the power 2, and 1 with 2 to the power 3. Similarly, beyond for the decimal part, the part after the decimal point or the dot, I would multiply 1 with 2 to the power minus 1, uh, 0 with 2 to the power minus 2, 1 with 2 to the power minus 3. Okay. So, and then what you would do is you would add all of this up, and you would find what is the value in decimal, right? So I think someone has already found that out, and it's 54. Okay. Yeah, maybe I have not calculated it. You can, I'm just telling you the procedure how to do this. You can calculate it, and yeah, there should be some decimal points because it is 10 to the minus
Sir, I
2.
have a doubt, sir.
Yeah, yeah, Bharat, go ahead.
Sir, actually, the computer uses the binary system, no, sir. Then why is there a need to learn the other octadecimal, decimal, and hexadecimal, sir?
Okay, so I've already explained this twice. So the decimal number system is something that you use in normal life. So that is something for the user comfort, right? You don't want to convert every number to some other number system before entering. If you want to enter that a is equal to 50, I want to enter a is equal to 50. I wouldn't first convert myself 50 to binary, and then I would enter a is equal to some 0 b something something, right? I don't want to do that. So yeah, that is why I use decimal. Like decimal is for user comfort. Then hexadecimal is a very high base system where the primary reason is to um, use it when we want to represent very large numbers. We just want to use hexadecimal. For example, if we want to store memory addresses, like uh, if we want to represent a number which corresponds to a certain memory address, we write it in hexadecimal, because that way we can represent a very large number corresponding to the memory address, in less number of digits, right? Because the base is high, we can use larger number of digits, and we can represent it in a very short manner, even if the actual number in decimal or in binary would be very long. Okay, I hope that makes it clear. Okay, so now I'm going to convert this hexadecimal to decimal and then to binary. So the concept is still the same. You start from this side, you multiply 16 to the power 0, 16 to the power 1, 16 to the power 2, and 16 to the power 3 to this four digits, and you add them up, and whatever you get is the decimal notation, that is the best 10. And then you can just convert it to binary, the decimal part, by by kind of dividing it by 2 and getting the remainder part, and then going from the end towards the start. That would give you, so you find some say there is a number, say 56, and I divide it by 2, the remainder is 0. Then I divide it by 2 again, the remainder is 0 again. Then I divide it by 2, the remainder is 7. Then I divide it by 2, the remainder is 1, and then divide it by 2. And if I want to continue this, so I can write it like this, and I go the other way, that is from the bottom to the top. So this is 1 1 1 0 0 0. So this is the binary notation for 56. So this is how you would convert a hexadecimal to decimal and to binary. Okay, so you can follow the same procedure. I'm not writing the answer here, but you can follow this procedure and solve it on your own. Okay, so now what is a programming language? A programming language is basically a method of conveying the instructions to the computer. You have a set of instructions, an algorithm that you have, or a flowchart, or a pseudocode, and you want to convey this set of instructions to the computer. That is what is the purpose of a programming language. Now, okay, give me a minute. All right. Uh, so there are three different kinds of like overall categories of languages. First you have the machine level language, which is basically the language that the computer understands. Then you have some assembly level language, and then you have high level code, which is the source code, or which is basically the one that you will be using in C, that you will write in C. That is basically high level language. That is not something that the computer can understand. So you need to pass this high level language or high level source code that you have written through a program which is either compiler or an interpreter, which will convert this source code to a machine readable form. That is the machine level language. So it will convert this to this. So this is done by a compiler or an interpreter. So a compiler or an interpreter is itself a program which will do this conversion from high level to the machine level form. An assembly level language is something that is still being used these days. It is more used for direct hardware access, and if you want to write some embedded softwares, like something that would directly be used by the hardware, you can still use assembly level language, but it's not that popular anymore. Like you can do such operations in many other languages as well, so it's not that popular anymore. Yeah, Manish.
Sir, is there any difference between pseudocode and flowchart?
Yes, Yes, there is a difference between pseudocode and flowchart. Pseudocode is basically you will write the entire algorithm in a non-technical form, and flowchart is a pictorial representation. You just go back and you can watch the lectures of week one. I think it has been covered in class, so you can just revisit the lectures and check that out. So flowchart is a pictorial representation. Pseudocode is basically you're writing it down in a non-technical form, but still it seems like a code, but it will not work on any machine. So it seems like a code, but you cannot directly use it on any computer, right? That is how a pseudocode looks like. And the flowchart, as you have seen, it's kind of pictorial. You have a lot of boxes and ovals and so on, each solving their own purpose.
And
Yeah.
sir, what kind of similarity they have?
What kind of
Similarity that they have?
similarity?
Yes, sir.
Yeah. Okay. So similarity is just that they're just different ways to represent the algorithm. Whichever you find easier to do, you can just use that. And there is the only similarity that they have is that they are used, both are used for defining or writing down a set of instructions, which is basically the algorithm. So that's the similarity that they have. But you are free to use whatever method of whether a pseudocode or a flowchart, whichever you want, you can use that.
Okay, sir, get it. Thank you.
Yeah. All right. Yeah, Uday Kumar. Yeah, I can't hear you. Can you just speak up a bit? Or you can just write it here. Yeah, you can just write it in the chat box. I cannot hear your voice. It's quite low. It's fine. You write it in the chat box. I'll look at it. Yes, an algorithm. See, pseudocode is basically a way to represent an algorithm. So, algorithm is when you would just write it down in English or any language. You would just write it um, down what you are supposed to do. That's a algorithm. You can write an algorithm for making a cake. Okay, but pseudocode is something that gives you a slightly more ordered manner of writing, slightly more ordered manner of writing a algorithm. So basically, it's a more so flowchart or pseudocode, whatever it gives you a particular way of writing an algorithm. Otherwise, an algorithm can even be written as step one is this, step two is this. Plain, you can write it in English. Okay, uh, that is the only way I can explain this, how an algorithm is different from a pseudocode. It's not really different. You're just representing it in a pseudocode, which is a much more very well-defined manner of defining an algorithm. But at the end of the day, both of them are fulfilling the same purpose. Both of them still won't work in a device if you directly enter them. Okay. All right. Okay. So there is a question. Assembler. What does assembler means? Okay. An assembly level language can be converted to a machine level language using an assembler. So every assembly level language, whenever you use a assembly level language, there is an assembler which comes along with the language itself, and that is responsible for converting the assembly level language to the machine level language. But assembly level language itself is not popular anymore. Like, it's hardly being used anymore because it's not really any, like, I would say it it serves a certain purpose that you can directly interact with the hardware, but you can do the same in C language as well. You can interact with the hardware. So yeah, nowadays it's not that popular anymore as it used to be. Okay, are there any other questions? Yeah, mnemonics. Okay. All right. Mnemonics is mm, right. I think it means the way that we used to write the algorithm or something. I have to check that out. I'll check that out and go get back to you. Okay, the mnemonics part. I forgot the definition, but yeah, I think it's something like that. Okay. If there are no more questions, I'll just go to the next slide. All right. So different types of memory, primary, secondary. Yeah. Yes. Go ahead, please.
Sir, excuse me, sir. Sir, yeah, assembly language is any importance in C language, sir?
I don't get your
In C
question.
assembly,
Assembly level
in
language is
C
different.
assembly,
No, no, no. See, assembly level language is
assembly.
different from C language. So C is basically you'll be writing mostly high level code, but C can also be used to access hardware, which makes it kind of a middle level language. Assembly language is completely different. The way of writing, the syntax, and everything is completely different from C. So, C is not assembly level language.
Thank you.
Yeah. Okay, so we have different kinds of memory. The primary memory, which is the RAM, the secondary memory, which is our hard disks, ROM, and we have other memories like cache, registers, buffers, and so on. Then you have 1 byte. So the memory is defined in bytes, and 1 byte is 8 bits. A bit is one keystroke, and yeah. So bit is the smallest unit of memory. And yeah, variables, you can think of variables as memory locations in the RAM, which is allocated during compilation. So it is basically a variable means a memory location. You have this entire memory, which is, say, the RAM, and there you have a small memory location allocated of, say, X number of bytes for which corresponds to, say, some variable n, right? So this n is, say, some integer variable or some variable that you have defined, and that variable will actually be allocated a memory space in the RAM of some x bytes. If it is an integer, it will be 4 bytes of memory that will be allocated to it, and that is what a variable is. And when you write x equal to y, what does that mean? So you have in your RAM, you have two different memory locations. You have a memory location which stores the value of x and a memory location which stores the value of y. So when you write x equal to y, what the computer does in the background is it will read whatever data is in y and it will copy it to x. So this memory location which stores the value of x, this will have, after the copying procedure, you will have in the memory location for the x, you will have the same value as in the memory location of y. So that is what happens when you write x equal to y. And what happens when you write x equal to y into z? So you have x, you have y, you have z. So this is y, this is z, this is x. Now what it will do is it will read y, it will read z, it will transfer it to ALU. ALU will do this multiplication part. It will do the multiplication part, and whatever output comes back, it will store it in X. So that is what that is how this would work, like X equal to Y into Z. Okay, it's directly, it's just memory and CPU interactions. That's all. All right. So now we come down to the tutorials. So I think this was the recapitulation of the week 1 lectures. So now let's just start with the tutorials, the example questions. So we have the first question, which is what will be the output of this particular flowchart? So I have shown you an example flowchart already. So um, I think you can answer this. So here this particular shape is being used for the input and output. I think that's the nomenclature that has been followed in the class. All right. So you're starting the flowchart. You're reading the x as 5. Like you have read a number x, which is 5. Now you're okay. I think that should be y. Yeah, there should be y. All right. So let's say y is equal to 5. You are reading a number. It is y is equal to 5. And then you are saying x is equal to y. So you are defining another number x, another variable x, which has the same value as y. Now I explained to you how the copying procedure takes place inside the memory. So you will have x equal to y, that is the value of y will be stored in x now. So you will have x equal to 5. Now what will happen in the next step? You are writing y is equal to x into 10 plus y percentage 2. So now what is the value of x? The value of x is 5. You are multiplying it with 10. And what's the value of y? Y value is 5. You're doing a percentage operation, that is a modulo operation. What a modulo operation does is it finds the remainder. So this operation will basically give you the remainder. Okay. Now what will be the value here? So 5 into 10 is 50, and you have 5 percentage 2, that is the remainder operation, that will give you 1. So here it is 51. Now you're just printing y, the value of 51 is going to be printed. So this, yeah, someone answered it correctly. So the value is 51 that is going to be printed. Okay, I hope that is clear to everyone. So if it is, let us move to the next question. So the next question is, we are reading, so same, what will be the output of this? So b is being printed here, and you have a number a is equal to 3 and b is equal to 2. We are reading these two numbers, and what we are doing in the first step is b is equal to a plus b, that is 3 plus 2, which is 5. Now we are doing a is equal to b is equal to a into b, that is 3 into b, which is now 5, plus b, which is 5 by 5, right? Now what this will be, 15 plus 1, which will be 16, and b will be 16, right? Is there a doubt in any of this as to why it happened like this? So b is equal to 5, and then you are again doing another operation, b is equal to a into b plus b by 5, where you can now b, in the previous step b has already become 5, so now you will replace a with 3 and b with 5 in this equation, and you just write it down. And if you write it down, you will find this 15, this is 1, you add them up, it's 16. So b is equal to 16, and that is what will be printed. So this is the answer, right? Okay, so let's move to the next question. It is another similar question as the previous one. You have two numbers a and b. A is 4, b is 6, and we do a set of operations on them. What we do is a is equal to a plus b, which is 4 plus 6, that is 10. Now b is equal to a minus b, that is 10 minus b. B is still 6. So after the first step, a has become 10. So here when we write the second one, we replace a with 10, and b is still the same, that is 6. So 10 minus 6 is 4, and then again we write a is equal to a minus b. So a is 10, b is 4. So now 10 minus 4, it's 6, and we print the values of a and b. So what is the value of a? It is 6. What is the value of b? It is 4. So the answer is 6 and 4. Right? Is there any doubt as to how this happened? Is everyone clear?
Yes, sir.
Okay. Alright, so let's go to the next question. So you have two numbers that are being defined initially. We have sum is equal to 0 and n is equal to 0, and you are doing n is equal to n plus 1. So let me write it down a bit properly. So sum is 0, n is 0. Now we are doing n is equal to n plus 1. So n became 0 plus 1, which is 1. Then we go to sum is equal to 0 plus n, which is 1. Now it is 1. Sum is 1. Now we check n is equal to 7. No, definitely not. And n is still 1, right? So n is not 7. So it goes again on the no route. It what does it do again? It does n is equal to n plus 1. So n will become 1 plus 1, that is 2, and then you'll have sum is equal to what? Sum is equal to 1 now, and then you add it with n. N is 2, so sum is equal to 3, and it checks again, is n is equal to 7? No, this means, is n equal to 7? If yes, if no, then go this. If yes, then go this, right? This is what it means. But we are checking that n is not equal to 7. Like the value of n is not equal to 7. So the value of n is 2. It's not 7. So because it's not 7, it will go to this route. It will go towards, the answer is no. Here when we ask, is n 7? No, it is not 7. So we go to the no route. And so again it increases n by 1. So 2 plus 1, you will have 3. Then you will have sum is equal to sum plus n. Sum is 3. You will have n is already 3. So you will have 6. Now again it checks if n is equal to 7. N is 3. So it is not equal to 7. So again it goes and increases the n value by 1, which makes it 4. Now it adds up in the next step. It does sum is equal to sum plus n. Sum is 6. N is 4. You will have 10. Now again it checks, is n equal to 7? No, it's not equal to 7. It's equal to 4. So it's not 7. So again it goes back. It does n is equal to 4 plus 1, that is 5. You do, in the next step, you do sum, which is 10, plus n, which is 5, gives you 15. Then you check again, is n is equal to 7? No, n is still not equal to 7. So you go back and increase the value of n by 1, which gives you n value of 6. And again you increase the sum, which is 15, by 6. You get 21. Then you check, okay, then you check if n is equal to 7. No, not equal to 7. N is equal to 6. It's not 7. So now it goes back the no route. It increases the value of n by 1 again. It becomes 7. Now you do sum is equal to, which is sum is 21. N is 7. So you have 28. Now it checks, is n equal to 7? Yes, it's equal to 7 now, because you had increased the value, it is now equal to 7, so it goes the yes route and it prints sum. So it prints out the value of sum, and sum is what? It's 28, right? So basically what this program does is it adds up all the numbers till the number 7. So it basically adds up 0 to 7, right? Okay. If anyone doesn't have any doubts, I'll just be moving on to the next question. Yeah, please go ahead. Yes, Sripada Rao, you can go ahead and ask any question if you have. No? All right. So let's move to the next question then. Yes, Akshita. Okay, you can write your questions in the chat box as well. That is also fine. Shailaja, can you just redo it? Maybe you missed some calculation somewhere or something. Did you understand how it came out to be 28? Is it clear now? Okay, yeah, if you have any doubts, you can just write them in the chat box. All right, so, okay, now I explain 8 question. Okay, yeah, the thing is, I cannot explain to you the questions from the assignment because the your assignment dates are still there, right? It's not passed yet. I think tomorrow is the submission date for the assignment, so I cannot explain to you the assignment questions. Okay, if you have any specific doubts though, I can answer them, but not the questions directly. Alright, so the next question is to draw a flowchart to extract all the digits from the natural number. Now, how do you do that? How do you extract the digits from a natural number? Alright, so let's say we have a number which is 756. We have some n value. Let us just think about it first. You can probably draw the flowchart on your own. Let me explain to you the algorithm, how you would go about. So you want to extract this digit 6 first. So you can do something like this, percentage 10. Now, if you do that, what will you get? Like, if you do any number, percentage 10, then basically what this modulo operator does, it divides it by 10, gives you the remainder. Now, if you divide 756 by 10, what would be the remainder? You would get 6 as the remainder, right? Now you are able to extract the last digit, which is 6. Now, how do we extract 5 now? I want to extract 5. So let's do something. Let us subtract this 756. Subtract this 6 from 756. Divide it by 10. So what will that give us? That will give us 75, right? Then we again repeat the same thing with 75. We do 75 percentage 10. What does that give us? That gives us 5, right? So we are able to extract 5. Now we want to extract 7. So what do? We do 75 minus 5 divided by 10. Now we got 70 divided by 10, we get 7. So you can probably repeat the same procedure or not. You still will be getting 7. So you're able to extract all the digits from this natural number. Okay. So is the algorithm clear to everyone? Now what would you really do to extract all the numbers, how would you write the flow chart? Let's say I would start it, and say I would, let me follow the convention that sir has covered. So you would enter some n, all right? So you would enter some n, and the first thing you would do, you would check. So now if you do the same thing, if I go beyond this, what would happen? So sorry. So 7 minus 7 by 10, because the number is 7 here, so it becomes 0, right? So my condition should be something like, is n greater than 0? Only when it is greater than 0, all of this stuff should happen. If it becomes 0, that means I have extracted all the digits now. I don't need, there are no further digits to extract. So if it is greater than 0, then I go for the yes part. Okay, now what do I do? First, I do some x is equal to n percentage 10. Now this gives me the digit, right? This is the digit I want. This is x. I need to print it out. So I just print out x. Okay, I print out x now. Alright, because that's the digit that we wanted. Now after that, what do? We deduct the digit from the number divided by 10. So I would say n is equal to n minus x divided by 10. This is our next step, right? Now after we reach here, what do we want to do? We want to go back and we want to check if n is greater than 0. If it is greater than 0, then we go ahead, do the same thing again. So what I will do is I will go back here and I'll check the condition again. Okay, now what if it is no, that n becomes 0? Then we simply stop, because that's the end. We have already extracted and printed all the digits, so we have no digits left. The n value becomes 0 already, so we'll just stop. That's the end of the code. So this is the flow chart that you would have to extract all the digits from the natural number. Is this clear? Assignment questions, probably you will get the solutions to the assignment questions. I think they will be giving you the solutions a few days after the assignment gets submitted. So, or maybe the same day, I don't remember. So you'll get the solutions for all the questions. But yeah, if there is any particular question that is ambiguous, I can check that out in the next class. Okay. All right. If there is no doubt in
Sir,
this,
can you
yeah.
provide the all question?
All questions, as in which question?
Sir,
Yeah.
can you provide the question?
Provide the questions, as
Sir,
in
can you provide the question?
which questions are you talking about? Provide which questions?
Sir, all questions.
All questions as in assignment questions?
Sir, actually, yes, sir.
The assignment questions are something that,
Sir,
yeah, go ahead.
no, sir, you just continue.
Okay, okay. All right. So, yeah, anyone else has any issues? Yeah, Animesh, you wanted to say something?
Sir, yeah, you
No? Okay. Okay, you're not receiving any update emails or something. Okay, but you have subscribed to the course, right? You can just log into the Swayam portal and check the assignments. They don't need you to inform about it. Like the emails, definitely it should be there. I don't know. You can mail to the NPTEL or the Swayam. There is a customer care kind of thing for the Swayam. You can probably mail them, or you can check if there is an option for receiving the emails and so on. But ideally, yeah, you can just log into the Swayam portal and check for the assignments, right? You can see the assignment questions there. At least I can see that week 1, I think week 3, up till week 3, the assignment questions have been already given out. And week 1 and week 2, the submission date is tomorrow. if I'm not wrong. So yeah. So this was all about week one. Whatever we have covered, hopefully it will be easier for you to solve the week one questions. Now we will be going on to the week two material, and yeah, so in week two, the first thing we had covered was the types of software. We saw there are different kinds of software that are available. Like you can have different categories of the softwares. The first is the system software. Then you have the application software. So in system software, you can uh, okay, the pseudocode. Yeah, the pseudocode can be written in different kinds of manner. It depends from person to person how you would like to write the pseudocode. So mm, yeah, I can probably do that for you. So I would write enter n. Then I would check, say,
Sir, can you show the 11th question? So 11th question. Can you show again
11th question.
types of
Types of what? Which one are you talking about? Okay, the 11th slide. Yeah, there's no question in this slide. We're just
yeah, yeah. Just a wait. I just take some picture. Okay, thank you.
yeah,
Sir.
sure. Okay, so you can write a pseudocode as in, let's say, mm, yeah, I can probably write while n is greater than 0, I can write x equal to n percentage, sorry, this is capital, right? N percentage 10, or you can write rem or something. Then, uh, yeah, Uday Kumar, if you have anything, you can just ask me. I think this was your question, right? So, yeah, so you print x and then you write n is equal to n minus x by 10. It's more or less the same way that you would write. Yes, yes, I'm writing the pseudocode for you. Um, and yeah, this is more or less what you would want to write. So you are entering n and you are checking while n is greater than 0. That means for the entire thing, the n should be greater than 0. Now I'm doing x equal to so this is within this part, like this is a mm, I don't want to say there is a braces or something. So this part is executed only when n is greater than 0. That's what this means. So x equal to n percentage 10, that you can see from here. I'm printing out x, then I'm changing the value of n like in the flowchart, and after this it will just go back here. I can write, say, go to okay, let me just rewrite it. It's fine. I'll write it a bit simpler. So this is line number 10, then line number 20 is if n is greater than 0. Then if n is greater than 0, then we go to x equal to n percentage 10. Line number 40 is print x. Then line number 50 is n is equal to n minus x by 10. Then line number 60 is go to 20. Okay, I think this should be good enough as your pseudocode. So you have entered n, then you have checked if n is greater than 0. Then if n is greater than 0, then you do all this stuff, which is n percentage 10, and you print x and you change the value of n, and then you again go back to line number 20. Okay, and this is basically it. Like, this is the pseudocode. Is that okay? So yeah, I need to mention here that there can be different ways of writing pseudocode. I think the professor has a different way of writing the pseudocode. I have a different way of writing the pseudocode, but finally the thing is it should represent uh, there are no rules regarding it, but there are certain conventions. There are certain, like, it's recommended you write it in a certain way. You can check that out for the pseudocode. But as long as it gets the algorithm through to the to whoever is checking it out, it's fine. Okay, so we have the system software that I was talking about, which interacts directly with the hardware. So you have the hardware in the center, as you can see, and the system software, it interacts with the hardware directly. So you have this operating system. For example, you have Windows, Ubuntu, and different kinds of operating system. So Mac OS and so on. Like you can have all these operating systems, and then the compilers and interpreters as well, because they interact with the hardware. Because after compilation, or in after the compilation, or the interpretation, the source code gets converted to the machine readable format, and the machine readable format is something that works directly on the hardware. So that is also kind of system software. The compilers and the interpreters are also kind of system software. And then you have the application software, which uses the system software in some way. For example, um, you would have you would be writing your code in an IDE, which is a integrated development environment. And that integrated development environment, say, you can use, whether you are using code blocks or some other IDE. So all of those IDEs, basically how they work is, they give you an environment to write your source code. When you compile it, you are using some system software to compile it, and when you run it, you're running it on the hardware. So they are dependent on the system software to have your code run and to get the results of your code. So your IDEs are a kind of system software. Then you have any kind of software, for example, the PDF that I'm showing you, the presentations, any kind of softwares. All of these are application softwares. For now, for example, you're on Google Chrome, that is application software. So all of this are built for a certain application, for a certain purpose, and they are application softwares. Okay. All right. So yeah. Now variables, as I have already told you, it's like, whenever you define variables, basically you're defining memory locations in the RAM, uh, and which are getting allocated to those variables, some memory locations to store some values. And the naming of values have a certain convention in, or rules, you can say, in C. So it should be a string of alphanumeric characters with only a few special characters which are allowed, which is underscore. And it shouldn't start with a number. It shouldn't be a keyword. So in keyword basically says that it has a special purpose in C. So it is reserved for a certain sense. If you write that keyword, then a certain operation will happen, or the compiler will take it as a certain operation which is already defined in the to the compiler. So you cannot use a keyword as a variable or an identifier. Okay, and remember that it's case sensitive, and it's recommended not to start with the underscore. Okay, and why is that really not recommended? So the answer here is option C, which is, it is not recommended to start a variable name with an underscore, because um, there are already some predefined library routines and macros, uh, which are already predefined to the compiler. Now, if you write the variable names, and if there is a conflict with that library, or that library routine, or those macros, then you will get an error. So it's recommended not to start the variable names with a single underscore. You can have multiple underscores, but not a single underscore. Okay, someone asked, what does it mean to be case sensitive? Okay, so basically, if I write case as this, and case as this, and case as this, all these three are three different variables. That is what it means by case sensitive. So it's uppercase or lowercase, or your each of your letters are uppercase or lowercase, it can be a different variable if it is so. Okay. So which of this is an invalid variable name? As you can see, the rules are here. We know that it shouldn't start with a number. So option C here is our invalid variable name because it is starting with a number which is 7. So it is a invalid variable name. Okay. Option D is not recommended, but because there is no library routine of the same name. Because there is no library routine of the same name, it is still okay as a identifier. Okay, so what case sensitive basically means is you can define three different variables with names like this. So case with a C capital and rest of them small, and case with C and A capital and A and S capital, E small, and case with CASE all of them small are different variables. That's what it means to be case sensitive. So the compiler considers all of these three to be three different variables. Okay, even though I am writing the same thing, but there is uppercase character and lowercase character together in different combinations. So as long as that is the case, it is case sensitive. Okay, all right. Now the basic structure of a C program. So a C program should have a main function, that is where the execution will start, and it can have more functions of that sort, and it has an inbuilt library of functions for different operations. So there is a large inbuilt library, predefined library that comes with the C language, uh, that is defined to the compiler beforehand. You just have to include those libraries. If you want to use the functions, you have to write an include statement followed by the header file. So this is the header file, and this is the include statement that you have to write if you want to use the functions of this particular library. Okay, so it has an inbuilt library of functions. All right, so now the I have a few questions for you. The first question is, in case of signed int variables, which of the statements is correct? Like, what is the case for the signed int variables here? So signed int variables basically means that it can have both, it can be both positive or negative, because integers can ideally be positive or negative, right? So for signed, when you say signed int variables, that means it can be both positive or negative. If I say it's a unsigned integer int, that means it can be only positive. It cannot be negative. Okay, so that is the difference between signed and unsigned int. So in this case, the correct answer is option A, that is the leftmost bit is reserved for signed. What exactly does it mean? Let's say that one int is 4 bytes. So when you define a int n, you have 4 bytes of space in somewhere in the RAM. So I'll just show you a few bytes. So like this, you'll have like 32. So 4 bytes means 32 bits. So I'm representing each bit by a box, and you'll have 32 bits of memory that will be allocated in the RAM for this integer n. Now, out of this, the leftmost box, that is this box, will be the one which will store the sign of the value that is being stored in n. Say n is minus 256. This will have one sign, and if n is 256, uh, it will have one. Otherwise, it will have zero. Right. So the sign will be stored in the leftmost bit. Okay. All right. So, Right. So let's look at the next code. So what will be the output of the program given below? We have a program which has a main function. We are saving a value of 9 to A. Okay, so let me make it clear. This is another question. This question. You have to tell me what will be the answer. I wrote 32 bits, not bytes. Yeah, because one byte is 8 bits, right? So 4 bytes is 32 bits. Okay, all right. So what will be the case here? Okay, fine. So here you will have a compilation error. It will give you a compilation error. Why exactly? Because you are not really specifying what kind of data type it is. Like, what is this A? What is the data type of A? You're not specifying the data type, right, in this. So if you don't write which kind of data type it is, it will give you a compilation error. So this question will have a compilation error. Like when you write this in any ID, any uh, C, if you write the C code and you try to run it, it will give you a compilation error. How to rectify this? You can write int. So int a equal to 9. If you write that, then the compiler understands that a is a variable which is of type integer, and you are trying to save the value of 9 in the variable a. So there will be no compilation error in that case. But in lack of this data type, declaration of a data type, you will have a compilation error. Okay, so okay, what about the next question? What if we declare int a? Yeah, if you declare int a, it will give you a value of 0. Like the printf will give you 0. Like in the modern compilers, it will give you a value of 0, because whenever you define an int, it is initialized to 0 in the background. But in the modern compilers, if you go for the older compilers, for example, I think Turbo C and so on, but it can give you garbage value in Turbo C. But the recent compilers should give you a 0 value, most of them at least. Okay, all right. So what about the second question? A lot of you have already written 19, so I'll just explain how it came out to be 19. So you start the calculation from the left side, and if you remember the operator associativity and operator precedence, you have star and slash operator, which has the same associativity, higher precedence. Then you have plus and minus operator, which are having lower precedence than them. If you just follow that, then you will have first, you'll multiply 4 into 5, became 20, by 2, which is 10, plus 9, which is 19. So your answer here will be 19. Right? So this has higher precedence, so this is the order of precedence. And when you talk about, so this is operator precedence. And when you talk about associativity, that means that how for a particular, say if you have here you have a multiplication and a division operator side by side. So how would this operation take place? So the associativity rule for this says from left to right. So forget about BODMAS rule right now. So how this is the associativity. Let me write it. So this is the associativity, which is left to right. That means that when you have multiple operators of the same precedence, for example, the star operator and the division operator, like the multiplication and the division operators, they have the same precedence. So in that case, we'll go to the operator associativity, and the operator associativity for this operator says that whenever such two operators comes in the same line, we always calculate from the left to the right. So we calculate from the left to the right here, and when you start from the left, the first operation encountered is the multiplication operation, right? So you multiply it first, you get 20, then you divide it, you get 10, right? And then you do a plus, which is of lower precedence, so it will happen at the end after these two operations are done, so you get plus 9. Okay, so this is operator precedence and operator associativity. I think it has already been covered in week 3. I'm not sure, I have to check. Probably it has been covered there. uh, okay. What if x is equal to 1 comma 2 comma 3 comma 4? What is that? Like, that is not a valid statement itself. Like, um, x equal to 1, okay, it can store x equal to 1, but uh, 2 3 4, then these are just integer literals. Okay, I'll just explain it again. Yeah, yeah, okay. um, so here you have uh, okay, there are two concepts: operator precedence and operator associativity. So operator precedence means whenever you have this operator, when you have operators of different precedence, the operator with the higher precedence will be executed. Like, the operation with the higher precedence will be executed first. For example, you have the multiplication and division operator here, and then the addition and subtraction operator. So multiplication and division operator have a higher precedence than the addition and subtraction operation. So whenever you have them in the same statement, first the multiplication and division operation will take place, and then the addition or subtraction operation will take place. Okay. Now what happens when you have both the multiplication and the division operator in the, how can you say? Okay, that is the precedence that has been defined for this programming language. Okay. There is no print statement. I have never said that it is going to print 19. The question itself asks what is the value of x in the C code. It doesn't ask whether you are printing it. You can print and check it out. The answer will be 19 anyway. But yeah, okay. So next, if you have the operators of the same precedence in the if you have the operators of the same precedence in the same line, what will happen then? Then we come to a concept called operator associativity. So operator associativity for this operator, which is the multiplication and the division operator, says that whenever you have the operators, multiplication or division operators occurring in the same line, we always go from left to the right while doing the operation. So here we start from the left. So from the left, the first operation that we encounter is actually the multiplication operation, not the division operation. So we do the multiplication operation first, which is 4 into 5, we get 20. Then we do the division operation, we get divide by 2, that is 10. Then multiplication and division operators done. So we go to the lower precedence operator, which is addition. We just do that and we get the value of 19. Okay, is that clear? Okay, if we declare int x is equal to, in braces, 1 comma 2 comma 3 comma 4, what will be the x value? So it will still give you a compilation error if you write it in this. Yeah, what about the, if you write int x equal to 1 comma 2 comma 3 comma 4, it will still give you a compilation error because x is actually meant to store a single value. You can define an array which will uh, uh, x will actually yeah, you can define an array which is x, which we will cover much later in the course, and you can store multiple integer variables there. But as such, if you write int x is equal to 1 comma 2 comma 3 comma 4, it should give you a compilation error. It takes the right value. What does that mean? Arithmetic operators. What exactly? What are your questions? Like, can you answer? Can you ask the complete question rather than just parts of it? So if I write x equal to 2 plus 4 slash 3 into, sorry, slash 5 into 3, what will be the answer? Okay. In that case, you have these two operators which have higher precedence. So first the division operation should take place. So you will have 2 plus 4 slash 5, which is zero point 0.8, I guess. Yes, zero point 0.8. Then you have, but because you're dividing within what? Within integers. So you have 0 because your x is an integer. You're dividing 4 by 5, both of them are integers. So both of them are integers. So you will have, okay, both of them are integers. So when you divide this, whatever you get, you will get an integer value. So you get 0 into 3, which is still 0, plus 2, which is 2. So you'll get 2 as the answer. Okay, we'll cover operator associativity and precedence. I have a table that I'll show you where it will all the operator associativity and precedence will be written down. I think that is in week 3. So I don't have it with me right now, but there is a complete table with all the associativity and the precedence rules. You can even search it out. I think Geeks for Geeks has a complete table. Will not give any compilation error. Okay. And why is so? Pramod, can you just answer that?
It is legal in
Huh? What?
It is legal in
Okay. Like, what exactly will happen? What will be the value of x in that case?
one.
Okay, it will just store the first value.
Yes.
Okay. Okay. All right. Yeah. But ideally, all the other values would be lost, right?
Yes.
Okay. Yeah. Maybe. Yes. If you have tried that out on the ID,
Yes, I did. Right now.
okay, cool. So, okay, for this case, it will be x equal to x equal to 1. Okay, and why is that? I'll just look into it and I'll get back to you. But okay, there are a lot of simultaneous questions. Let me just go through. Abdul Karim, what was the question that you wanted to ask? Like, is this the question you're talking about? Okay, okay. So you're saying that the answer is 3.6, but you are defining x as an integer, right? You're writing int x is equal to 2 plus 4 by 5 into 3. So how can you get okay, okay, fine. So the doubt is okay, Abdul Karim, first you try it with int, write int x equal to 2 plus 4 by 5 into 3, and then you can ideally you should not be getting an answer of 3.6 because it's an integer. All right. Okay. The doubt is that we want to divide, then multiply, then multiply with 3, then we want to add with 2. And why is that? Yeah, with float you will get a different result because 4 by 5 you will get 0.8 into 3, which will be 2.4. You will get 4.4 as the answer. That will be different. Abdul Karim, this is for you. Yeah, if you take float, then it will be different. You will divide 4 by 5, you will get 0.8. You will multiply with 3, you will get 2.4 there. So then you will add 2 plus 2.4, which is 4.4. You will get 4.4. This is the case only when you write int x equal to this. Okay, if you write float, then the answer should be 4.4 because 2 plus 4 by 5, 0.8, right, into 3, 2.4 plus 2, 4.4. Okay, now they will mention some kind of data type, unless that is the question, like depends on the question what they are asking. So yeah, they will mention the data type ideally. Only then, like if it's a float, then you will have. Okay, next we'll be going on and seeing macros. When you write that, then it takes in float automatically. I'll go to that. I'll go to that. So what operation we need to perform, which is having higher precedence and so on, and multiplication is high or division is high. It doesn't. Both are having same precedence. Like I said, the multiplication and division operators have the same operator precedence, and when you have two operators with the same precedence used consecutively or in the same line, you go for operator associativity, and the operator associativity for this particular set of operators, that is this multiplication and the division, is from left to right. So in this case, because you are getting when you go from left to right, you get the multiplication operation first, so you will do the multiplication operation first, and then you get the division operation, so you will do the division operation second. But if I had written 4 by 5 into 2 plus 9, in this case, when I go from left to right, I would have done the division operator first, and then I would have done the multiplication operator, and then finally the lower precedence operation, which is addition. Okay. Is that now a bit more clear, Manju? Trilochan, I am going to answer your question. I'll have to look into it. It should, as someone said, it should be x equal to 1. That's what it will store. I have to look into it exactly what is happening there. Even I don't remember what is the operator associativity for the assignment operator because yeah, that was in week 3, so I have not really looked at it. But yeah, I'll just look at it and I'll get back to you. Okay. And regarding anyone else, does anyone else has any doubts here? Okay, I'll get back to this assignment operation associativity. Just give me some time. Okay. All right. So let's go to the next question. Uh, okay, you have. All right. So this is about print formatting. There can be. You might recognize some of this control characters here, which is %d for an integer, percentage f for a floating point, and percentage, then you can have percentage 2.3 percentage c, which is for character, and this percentage 2.3, which will represent the number of digits that you want total before decimal, and so on. So yeah, there are.
Sir, I cannot understand. Sir, I cannot understand what is the print formatting.
Okay, yeah, I'm getting to it. I'm getting to it. So, okay, when you write a printf statement, for example, uh, say I write this, say n is an integer, and you're trying to print n, I'm saving say 50 here. So basically, how do you want the printing to occur? Like formatting the output. This is print formatting, means formatting the output. That is how you want it to be printed. Say I want to print there's a number 50.2345. Okay, there's a number say 50.2345, but I want to print only the first two digits after the decimal. So I'll just write in the printf statement, I'll write percentage point to f. Okay, and this, whatever this number is, say x, just write x. So that means when I write point to f, that means it will print only two digits after the decimal. Okay, it will print 50.23 in that case. Okay, this will give you 50.23. Uh, 50.23. All right. So
Yes, sir.
yeah, so that is what I mean by print formatting. Now if you want, say after the printing is done, you want the next line, whatever is uh, to be printed on the next line, not on the same line. So you can use this escape sequence, which is basically, which gives you a new line. So it prints, say you did some percentage d, then you write slash n. That means it prints the value of n. So you wrote the same thing. I can write another printf here. So basically it will
Yeah.
print 50, and then whatever next will be printed from here, not here, here. So basically we'll go to the next line. So these are escape sequences. So there are different kinds of escape sequences. You can have new line, you can have tab space, you can print a slash, you can go backwards, and so on. You can look into the numerous escape sequences that are present. Okay. So what happens when I try?
Point two means it is giving the values after the decimal point two. If you are giving 2.3, then what will be the values?
Yeah, that's something that you have to answer. I'll answer that. Wait a moment. So as let's first solve this question, which is, we are taking a float, we are saving the value as 57, and we are trying to print it as a floating number. Now what will be the answer here? So answer here, you will have this. This will be your answer. Like this is what it will print with 6 zeros after the decimal, because that is percentage f, no print formatting, like no uh, number of digits or number of characters that you are specifying here. So it will just print with whatever maximum it has, which is 6 zeros here. Okay, so this is what's going to be the answer for this one. And okay, so now let's go to the next one. So what is the output of this particular thing? So we have a, which is um, 4512.6526. Now what happens when we do percentage point 3f? Anyone? I think someone has already, people are answering it. Okay. Uh-huh. Yeah, have you tried this out on the code? Has anyone tried this out on the IDE? What it gives as the answer? Yeah, try it out on the IDE, like any
Sir,
IDE. Yeah. Yes.
Four by one two point
What?
652.
652?
C is the answer.
Okay.
C is the answer.
Okay. Did you check it on an IDE?
ID, okay, sir, 6.3F, percentage 6.3F. 0.3 means after decimal point, 3 digits to be outputted.
Yes. Okay. But when you have like it's not 3 digits to be outputted. Is it 3 digits to be outputted or 3 significant digits to be outputted?
After decimal point.
For decimal point, it gives the 3 digits after the decimal point.
Three digits or 3 significant digits? That's the question. Like, is it 3 digits after decimal or 3 significant digits after decimal?
3
Maybe
significant digits.
significant.
Which is the case? If it is 3 significant digits, then what are the 3 significant digits after decimal here?
6, 5, and 3.
Right? So I want you to try this out on an IDE, on online GDB or wherever you code, like you write programs. Yeah, that's what, right?
Yes, right.
Okay. So basically, this percentage dot 3f, what it does is not this. It does this. Have you tried it out on an IDE? I want you to try it out on an IDE. I think someone has, and they are saying D. Is it? Can others also try it out? It's not a very large code to write. I think you can write it immediately and check it out. Right. Okay, so the 3 significant digits here after the decimal are 6, 5. It should be 2, but what happens? What is the fourth decimal? What is the fourth digit after the decimal point? It's greater than 5, right? So the 3 significant digits are 6, 5, and 3. Okay, so here the 3 significant digits is 6, 5, and 3, not 6, 5, and 2, because you have a fourth decimal, you have a fourth digit after the decimal point which is greater than 5. So basically your significant digits are 6, 5, and 3. So here you will have this as this will be printed. So that is option D. Okay. If you're not very clear on the significant digits thing, you can just go back and look at it. What exactly is a significant digit? Like especially when you talk about truncation to a certain number of significant digits after the decimal, just you can go back and look at it. How exactly it is calculated. But yeah, so this significant digits here will be 6, 5, and 3 if you're talking about three significant digits after the decimal. Okay, now what if I had printed, say, how many? 4, 7, 8, 10.3f. What would it have given me? Like, what would be the answer in this case? Is it the same? No, it should not be. It should not be the same. You can try this out on an IDE as well. Just change zero point 0.3 to 10.3 and see what it will give you. Yes, it will give you spaces. Why will it give you spaces? Because uh, you can calculate the number of characters that are being printed here. 4 plus 3 plus 4 plus 4, which is 8 characters. It should give you two spaces, and then 4512.653. So 10, basically you're saying that the entire output should be at least 10 characters long. The entire output should be at least 10 characters long. That's what you are saying when you are writing 10.3, like percentage 10f. That means you're saying that the output, whatever you are trying to output, should be at least 10 characters long. So in this case, the total number of characters here are 8, right? Including the decimal point. So it is 8. So it will give you two spaces, and then it will print this value, which will give you a total of 10 characters that will be printed on the screen. So this is basically how print formatting works. Okay, I hope it's clear now. Not 6 spaces, Harsh. It will be 2 spaces. Okay, fine. So let's go to the next question. So you have, I think this question will help you in answering the assignment questions. So, okay, let's look at the first thing. So, what is a macro? First, let's understand that. So, this line is what is where we are defining a macro. So, here we are defining a macro. Okay, okay. In this case, okay, we'll see. We'll see what is the answer. So, we are defining a macro, which is A. This is the macro, and we are saying that it has the value of 6. So that means whenever A is encountered within the code, it will just replace it with the value of 6. Okay. Now, what we are writing in the code is int A is equal to 3, A is equal to A plus 1, and we are printing the value of A. So what will happen here? So we will have a compilation error. Why? Because a macro,
Sir, before already we have defined a value as 6.
yes, a macro cannot be redefined within the code.
Sir, okay, sir. We cannot change the value of the macro within the program.
You can redefine it, but you will have to again use a certain keyword for it. You can redefine the macro, but you have to use a certain keyword. You cannot cannot define A as a variable anymore. A is already a macro. Okay, you cannot define it as a variable. This itself is wrong. Okay, so yeah, you will have a compilation error here. You cannot if you want to redefine, yeah, I don't remember it exactly, but you can just look into it. Yeah, yes. Did you have any doubt? There is a keyword for redefining a macro. Yeah.
Macro value
We couldn't get you actually. Your voice is kind of. You can write it in the chat box if you.
in the value.
You can write it in the chat box, Satyanarayan, because I'm not able to hear what you're saying. So if you basically what I'm saying is if you have a macro, that is you're defining this, you have used a define keyword to, like, you're defining a, which is, this is the macro that you're defining, and this is a macro that you're defining, and you have a value of, you're defining that whenever a occurs, it should have a value of 6. Like, rather, the value of this macro a is 6. That means whenever you have a occurring in the system, you will have, it will be simply replaced by its value, that is this 6 here. So, and you cannot use a macro that has been defined. Okay, rather, let me not say it as a macro. Let me say that it's a constant, right? Let me just cut this out. Let me say it's constant. Okay, for, because a here, the way that we are defining it, this is a macro, but this is a constant. Like a is not a macro, a is a constant. We can also write it in this way. So we are writing as define a 6. We could also write a equal to 6. So we can use either of this to define a constant. Uh, yeah, so both of them serve the same purpose. We are basically defining a, here we are defining an integer a, which is having the value of 6, and we are using this keyword. This is a keyword, and it basically means that we cannot change the value of this particular variable, which is a, within this code. Like, within the functions, we cannot change the variable in the value anymore. Similarly, we can define it as a macro, which is a, and which has a value of 6. And once we do that, we cannot write this int a statement. Int a is equal to 3. We cannot write that statement technically, uh, because we have already defined a as a macro. We cannot redefine it anymore inside the function. Okay, so that is why it will give you a compilation error. Yeah, the PPT and everything will be given to you after the class, like few hours after the class. All right, so what about the second question? I think you have a very similar question in the assignment. You have a function, not function, it's a macro, which is fun of x. And whenever fun of x is encountered, it will basically do x into x minus x. So basically you're doing x square minus x whenever fun of x is encountered. Now you write a void main, you do float I is equal to 37.0 by fun of 2. So fun of 2, when you write fun of 2, what will happen is it will simply be replaced by this thing, 2 into 2 minus 2. Right. So what will happen here? And notice that there are braces here, like there is parenthesis here. So what is this? 4 minus 2, that is 2. 37.0 by 2, which will be 18.5. So that is what 18.50 is going to be printed, because you have percentage, like percentage point 2f. So it will have 18.50. This will be your output here. Right. Okay. So now a few more questions. I think this is the last slide that I have for you. Yeah, I think so. All right. So you have a variable var. You have a variable var, and you have defined it as this, and then you're adding 7 to it, and you're printing the value out. So what should be the answer here? Can someone tell me? Can you try it out on an IDE? Try it out on an IDE. So basically what this percentage D stands for, that is something I wanted to cover. So D stands for decimal. It doesn't stand for integer, it stands for, like, here the D stands for decimal. So you're printing it out as a decimal. The VAR, the value of VAR, you're printing it out as a decimal. So basically when you write anything, any number starting with a 0, this is octal. Right. 79 is the answer. Okay, but why? Like, we need to know why, right? So 0, 1, 0, 0, this is the value that we have written. So when we write var or any variable, say int, any variable, it starts with a 0. It's a octal. This starts with 0. It's a octal. Okay. Now what is the octal? This is the octal part. 110. This is the octal part. So 110, what is octal is base 8, right? What will it be in base 10? Can anyone calculate that? 72, right? Yes. Okay, so 72. Now, because now basically you are saying that VAR is equal to 72 and you are adding it with 7, making the value 79. I'm talking about decimal. This is all in decimal. Okay, so 79. Now percentage D, VAR, 79. Yes. Now, what if you wanted to write it, say, binary or something, right? You write 0B, then whatever the hell you want, 0, 0, 1, 1, 0, 1, 0, 0, whatever. This is binary. This is a binary number. You have to convert it to. You have to convert it to decimal. Now, similarly, int var 0x a 9 5 b whatever. So this is a hexadecimal. Yeah, the question asks us to add 7, right? var is equal to var plus 7. So that is why we add 7 to the number. So these are the different ways of entering a octal, binary, hexadecimal number. Decimal can be directly, you don't need any prefix for that, but for octal or for binary, for hexadecimal, you need all this prefix as shown here. Okay, so yeah, all right, let's go for the last question of the day. So what is the value of B after the execution of this particular C code? Okay, before that I'll just repeat this once. So here, because we started with a 0, the compiler automatically considered this to be a octal number. So if you convert this octal number to a decimal number, 110 in octal would be 72 in decimal, and when you're adding it with 7, which is a decimal number, it will add it to its decimal counterpart, which is 72. The final output will be 79. That is what is being printed here. Okay, so what happens here is a is equal to 7, b is equal to 10. Now we do a is equal to b, that means a is equal to 10. When we do b is equal to a, then b is equal to 10. So the 10 is the answer. You're right. Yeah, I got that. So a lot of you have answered as 10. Right. Okay, okay. Uh, right. Oh, there are two more questions. Okay, I saw that there are a few questions. Why do we do return 0? And there was another question as to if we write define A6, then what kind of data type is A? A is not a data type at all. It's a macro, or it's a constant, you can say. Yeah, but it doesn't have a data type. If like if you are writing 6.0, then it will replace it by 6.0. If you're writing 6, it will replace it by 6. If you're writing 6 into x, you're writing a is equal to 6, a of x is equal to 6 into x, then it will replace it by that. That doesn't mean it has a data type. Yeah, it's kind of an inline operation that you're doing. What's the difference between int main and void main? Okay. Yeah, this is more related to why we use return 0. So there are basically, you will learn with functions. Okay, what will happen if you use percentage x? Percentage x, I have to think about it, like what exactly percentage x was for. I don't remember it. Yeah, maybe for an address. You can use percentage p as well for for the address. But yes, I guess you can check that out. It's a simple Google search that you can do. Okay, so void main, and let me just write this down. So you can do a void main, and you can do a int main, but you have to return 0. All right. So what happens in either of those cases? Void, basically, this is basically the function prototype that you are writing, the function definition that you are writing. So this is a function name. These are the arguments that you are giving, and this is the data type. Sorry, this is the data type of return. Okay, like what kind of data type you are returning it as. So this is the data type of the return variable, of the returned value, I would say. Okay, so void means there is no data type here. It is not returning. In fact, there is no return. Void means the function is not returning anything. Okay, and int means it's returning an integer value. Now, if you have written int, you have to return something as a dummy variable or a dummy value. It's doesn't matter. You can return 1, return 2, return 100. Doesn't matter. You just have to return something. You have written it as int. That means your main function is supposed to return some integer value. So you just return some integer value. Okay, that's basically why. I think, but in the week 3, if you don't return 0, the current compilers will still run fine. It will assume that you are returning 0. Um, so the current compilers won't have any issues running, even if you miss the return 0 statement, it will still run fine. But ideally, if you go for strictly like the strict syntax is that you should return something. If you are written, if you have written int main, then your main function should return an integer value, no matter what the value be. It should return something. Okay, but yeah. Okay, that is the syntax that has been defined, Sailaja. The header files have to be encapsulated, or not encapsulated, but it has to be mentioned within those braces, that angular braces, or you could say greater than, less than symbol, or angular braces is what I call them. But yeah, that is the syntax. For example, why do you write int? Right? It's the same logic. Okay, let's see the last two questions that we have. Okay, so here we have a is equal to 7.0 and we are trying to print. So here 13 by 5, note that both are integers. Okay, and we are trying to do an operation on them, a division operation on two integers. No, returning something is not the same as printing something. Return something means your code, your function is returning it to wherever it is, returning the value to whoever has called the function. Printing means you can print whatever you want. It will come up on your screen. Return means it goes to wherever the function has been called from. Okay, so it's not the same. So we'll look into it at more detail when we go through functions. There is an entire week for functions which will come about later. So we'll look at that then. So here, as you can see, both are integers. It's 13 by 5. Yeah, Salja, you can also write them in that format. So header files can be written like this, but this is usually used for user-defined header files, like kind of the notation. This is for predefined header files. That is kind of the notation that we use generally, but yeah, like it's flexible. Okay, so 13 by 5 both are integers, so when you do this operation between two integers, it will give you an integer. Okay, so it will give you what, 2, right? Because it will give an integer. It will just ignore the entire decimal part, so it will give you 2, and 2 into a, this is 7, which is now 14, and adds 10, so you have 24, and that will be okay. This is all double zeros, sorry about that. So it will be 24.00. Okay, because here we have percentage point 2, so 2 digits after the decimal, so it will give you 2 digits after the decimal. Here both are zeros. So if you write 2f, it will give you just 24. Sorry, it will give you 24.00000, all 6 zeros. Oh, sorry. If you write percentage 2f, okay, then it will give you this, because 2 is the minimum number of characters that it can print. It can print definitely more than that, and here you are not specifying how many decimal digits, so it will print all 6. Okay, but okay, here I'll just explain this again. Okay, so here we are doing operation between two integers, so whatever it will give you is an integer itself. So 13 by 5, it will give you the actual value is 2.6, but it will take only the integer part, it will take only 2, and then it will multiply it with a is 7.0. So once it multiplies with 7.0, it will become 14.0, and then you add it with 10, it will be 24.0. And because here you are writing point to f, percentage point to f, it will print up till 2 digits after the decimal point, which is 24.00. Okay, I hope that's clear. Now if I had written, instead of percentage point to f, I had written percentage to f, that means I want the output to be at least 2 characters, so it can be more than 2 characters. So we are not basically, yeah, we are basically saying that whatever output I get, it should be at least 2 characters. So here it can be, that means, and you are not specifying how many digits after the decimal. So it will print whatever digits it has after the decimal. So all 6 zeros will be printed along with, it can be more than 2. So this is at least 2. Alright. So that is why you will get this as the output. if you do percentage 2f. I don't understand your question, Trilochana. Can you just explain what do you want? Sailaja, regarding the header files, I said this is the usual notation. Like this is the usual notation, but it's not necessary. You can use the predefined header files with this as well. It's fine. But this is the kind of a convention that we use when we are writing code. If we have a user defined header file, we give it within this inverted double inverted commas, and we write the predefined header files within this angular braces. But you can use either of them or for both the purposes. It's fine. Okay, now let us just see the last question. Uh, Okay, so we have x is equal to 1, y is equal to 3, t is equal to x. So t will become what? T will become 1, right? Then x equal to y, so x becomes, so x equal to 1, y is equal to 3, t is equal to x, which has a value of 1. Now x equal to y, that means it's 3, and y is equal to t, which is 1. So when we print this x and y, what is x and y? Which is 3 and 1. So yeah, the answer basically we are swapping the numbers, the values are the numbers. So it's 3 and 1, that is the output. I think this is pretty straightforward, like it's kind of clear to you. Okay, so that's all I had for the week 1 and week 2 classes. All right. Okay, so there were a few questions that remained unanswered. One was, let me just write them down here so that maybe we can discuss it in the next class. So one is when we write x equal to 1, 2, 3, 4, what is the value of x? So this is one of the questions. And then there was a question regarding mnemonics. And yeah, I think that's more or less what it was. How are macros saved? Okay. So if we write percentage %f in printf, it means it prints what it holds. How do operation direct, like multiply? Okay. So basically, no, wait. When we write this percentage point to f, that means we are printing a floating point. We will give a floating point value to, like this is a placeholder. Basically, this percentage f is basically a placeholder for some value, for a floating point value. Okay, now whatever value we provide to it, that is what it will print. So the value that we are providing in this case is this entire thing, not just a. It's not related to a directly, but it will take whatever value we are providing it here, and we are providing it something which has to be like operated on first, and then the value will go to the printf statement. Like we'll go for this placeholder percentage point 2 and will be printed. So yeah, in this case it will not take the value of a, but whatever the floating point data is the result of this entire part, one floating point data, because there is only one placeholder that we are showing here. So there is one floating point data that should correspond to, uh, it should take its place. That means, so this entire value will be calculated, and that will go to where percentage 2f is present. Okay, so yeah, so that was probably in a few hours or so it should be available. The session should be available on the NPTEL, on the Swayam website, on the course page. Yeah. Okay, so that will be all for today. Thank you for joining. The next class will be on the next Tuesday at the same time. and there I'll be covering the remaining questions from today, and we'll be covering the week 3. If you have any doubts in week 1 and week 2 assignments, like question number 4, I think, was someone asked for question number 4 and question number 8 to be explained from some assignments. Can you just remind me in the next class for that? And apart from that, we'll discuss the week 3. We'll go through the week 3 content, and um, we'll solve a few questions on that. Thank you. See you next Tuesday.
Thank you, sir.
Thank you, sir.